Andy and I are really happy to be here at DevSecCon 24. Really excited to tell this talk where we're going to be telling you stories about 5 different security incidents that basically Andy has lived through in his previous life at CISO, as CISO at Akamai, and talking about what they mean for building secure systems, specifically for supporting access to infrastructure. So who are we? I'm Sharon Goldberg. I'm the CEO and co-founder of BastionZero. We also have Andy Ellis, who is an operating partner at YL Ventures. Andy and I have known each other for about a decade, me coming from a research background, and previously Andy worked as a CISO. And here we are in our new roles as CEO and VC. So I guess we'll just get started. Yes, Andy?
Yeah, let's do that.
Let's do it. Okay. Yeah. So, what we're specifically talking about is administrative access to resources in the cloud. So a lot of organizations, and I think everyone here is familiar with building systems to keep outsiders out of your cloud. You don't want arbitrary people getting in and accessing your system. So we've got firewalls, we've got software gateways, we've got intrusion protection systems, all of this stuff is there. But at the end of the day, you may still need your incident responders, your SREs, your DevOps folks still need to get in sometimes to be able to see what's going on when things break. And really sort of locking this access out is very hard to do for a lot of organizations. So what we really want to talk about here is administrative access, sort of insider access to cloud environments, and security principles that are important to consider when you're providing this type of administrative access. And this is going to be a history lesson in 5 acts. Andy, what are the acts?
So our acts start in 2001 with Fluffy Bunny. We're going to jump forward and talk a little about Operation Aurora in 2009, then the Diginotar incident in 2011, and then we're going to wrap up with NotPetya and Solarwinds for some recent history.
We're going to go from a 20-year history of different incidents, many of which Andy had to actually deal with when they were happening in his environments. So it'll be fun to hear from Andy about some of that. Okay, so let's start with sort of the classic architecture that is still in place in a lot of organizations and is very dear to my heart as the CEO of BastionZero. And so this is a Bastion architecture. So in the classic Bastion architecture, what you would have is you would have an engineer that has an SSH key. You have a Bastion host that's got a public IP. This engineer is able to SSH into the Bastion host, and from there can use this Bastion host to access infrastructure inside the cloud, some of which may be on private IPs. In this particular example we're going to give, we're going to actually walk through the Fluffy Bunny incident. And so this particular Bastion host that Andy and I have here has an SSH key that allows access to one of the targets that's actually sitting on the Bastion host. So the Bastion host itself is housing SSH keys. I want to mention that a lot of organizations may not have this SSH key actually sitting on the Bastion. They may have it actually sitting on the user, on the user's machine. But in any case, that's what we're going to start with. And Andy, why don't you walk us through what happened in 2001?
And in fact, in 2001, it's even worse because many of these systems are using SSH passwords. So just pretend that key is actually a password. And in this case, the adversary would compromise someone's machine, doesn't matter whose it was, and they would just replace the SSH client. And what that SSH client would do was log keys and passwords, but not passphrases. This is the one sort of saving grace of this incident, is that it doesn't log the passphrase that encrypts the SSH key. But when the user logs in, now the adversary has that credential, the password, and then they log into the Bastion host the same way that the user did, uses the local privilege escalation to get root access, replace the SSH client, and now when someone logs in from that Bastion host to any machine, the adversary gets their credential and is able to connect further. And this adversary basically moved through a number of environments, level 3, Akamai, a number of other places, just sort of collecting SSH passwords and what systems they were good at going after. So taking advantage of these points where you'd collect, because one user would log in and now you would get 50 users' credentials or 100 users' credentials.
So it's like a really, to me, really incredible attack in the sense that this adversary just ripped out your SSH client, replaced it with malware that exfilled the keys and just kept moving laterally through, stealing credentials in this way. And this was 2001. It's kind
2001,
of
2001, and And this attacker group actually got really excited because they knew they'd breached Akamai. What they didn't realize is that our deployed network, what they really wanted to have control of, used SSH keys to log in, not passwords. And since they weren't copying the passphrases, they didn't get access to that. Instead, they just had access to, developer systems, managed to steal some old source code. They thought that would be really helpful to them. And we were very fortunate that we just detected it quickly and were able to purge it out of our environment.
So why don't you walk us through sort of some of the lessons that Akamai learned and that we can all take from this type of incident?
Yep. So first of all, important lesson is don't try to get to perfect in an incident. What can you do very quickly to make it better, and then incremental steps. So, eliminate the standing credentials. We actually segregated our Bastion hosts so that the ones that were being used for people to get into their desktops were not the ones people were using to then connect out to the deployed network. We wanted to separate those, and those hadn't actually been separated. We moved away from storing credentials on those hosts. It took us a while to do that. So, migrated to SSH identities. Then it was identities that were being, put into an agent on those Bastion hosts. And then eventually it was a transparent proxy. It was only transparent to the user, where you would log in and your credentials would, allow you to splice to a forward connection to where you wanted to go to. So each of these were trying to remove that single point of compromise, or at least reduce its scope. If you have that thing that is that valuable, allowing lots of users to log into it was certainly a problem for us.
And I want to highlight, one of the interesting things about this incident was that the adversary was able to exfil these credentials and then use them later. And so what this really points to, sort of for modern architectures, and I think most people listening to this already know this, is that standing credentials are bad, right? And the reason they're bad is because if they get stolen, they can be used in the future, and that's what you don't want, right? You do not want to be relying on these credentials that are super long-lived.
Yeah, so certainly in the case here where you're using sort of this two-stage credential, maybe getting the user's credential to rotate quickly is hard, but that second stage credential you can have on an automated rotation system. So even if it's exfilled, it's a smaller window that it's useful.
Right. Okay, so now another classic architecture that we're all familiar with, so VPN. So why do we have VPNs for access? Well, because we have this notion that the user, which is out in the internet, like here, me on my laptop at home, I shouldn't be able to access these targets in the cloud just like that. They should be sort of hidden somewhere that I can't get into. So essentially what we have is a bunch of targets on private IPs, and then a VPN that we can use to access these targets. And so what I find really interesting about this is that this incident that Andy's going to talk us through in a second is Operation Aurora is sort of like the classic a classic example for why just sticking your stuff behind a VPN is not necessarily going to be good enough. So why don't you walk us through what happened here?
So this one's interesting in that we don't actually know all the details of what happened because the adversary had such a long dwell time that the first way that they got in, we really didn't understand. And a challenge of this architecture in general is the philosophy people end up with from risk compensation. They say, oh, look, I'm behind the firewall. I can't have adversaries connecting to me. So if I don't patch my system, it's not the end of the world. If I don't harden the system, it's not the end of the world. So what happens here is first, the adversary gets access to some machine. Now that could be a spear phishing attack, compromises a desktop, any number of ways. We don't actually know how they first got in, certainly to our enterprise. Because we get notified like a year later from, of all people, Google. Heather Adkins calls me up one day and says, hey, by the way, you were compromised because we're now running the command and control server for this botnet because it had been abandoned. So they just grabbed the domain name and saw who was connecting to it. But once the adversary's in, now they're in this like soft, squishy inside. And so they can move laterally inside the environment until they find the systems that are going to be interesting to them. And they're often not doing things that are obviously bad. Certainly from a network perspective, they're not running crypto miners that are going to be noticeable because they're looking very carefully for something of value. In this case, the system in our environment that they got on was financial reporting software that we use to do our public earnings announcements. But in a lot of enterprises are also used to do things like validate which line of code is the most profitable one in your business. We didn't have that module, but you can see how that would be a very useful thing for an adversary to get, is your entire source code indexed by how profitable every module within it is.
And so, you know, in terms of the takeaways, this is sort of the lesson for all sort of modern segmentations of clouds and networks, right? So what happened at Akamai, you know, after this happened? What did you guys change?
We started a 10-year initiative. So sometimes you move really slow, sometimes you move fast. You know, one of the things we did that's going to be relevant in a couple of our history lessons was segmenting our user permissions, our administrator permissions. But really, this is where we start to segment our architecture, and, you know, don't base trust on network location, which many of you may recognize as one of the core principles behind the whole zero trust movement that becomes popular. And who are sort of the two big companies that push zero trust plays over the last 10 years is Google and Akamai, both of whom were breached in Operation Aurora. So what you start to see is this movement to say, how do we do, you know, authentication at the application layer? How do we ensure that you just can't talk to ports if you don't need to? That if I'm, you know, a user, I should be able to talk to a web service, but there's no reason for me to talk to any other protocol on a server because I'm not an administrator. So we don't just say, oh, you're inside the firewall, let's give you access to things. And in fact, at the culmination of our 10-year journey, we kick our users outside the firewall. Most employees at Akamai, by the day I left, were not ever inside the VPN. Everything they did came over proxied web, you know, connections, so that we didn't trust them just because they happened to be employees or physically located in one of our buildings.
So Andy brought up zero trust, and I actually think that's a great segue into the next sort of set of slides. So so this is a little bit of what zero trust access looks like today in a lot of products that are out there in the market. And what's happening in these types of architectures is the goal is to get rid of standing credentials, right? We don't want to have Alice over here, you know, here she is. We don't want her to have a key that lives forever because we worry about Fluffy Bunny coming in and exfilling that key and using it 6 months later to hack our systems, right? So we want to give her short-lived credentials, short-lived access. We want to segment access, right? So we want to, when Alice wants to access a server, we want to first validate, like, does she even really need access to this server? Does she have a policy or a role or an authorization or whatever your system may do that justifies giving her access, right? And so one of the ways to do this is to have Alice come in and go to some sort of authority and say, hi, I'm Alice. She authenticates to the authority, and then she gets some sort of credential that gives her access to the targets. And in this example, we're looking at certificate authorities as one way of getting this credential, right? So here's an example of a certificate. This is going to be a short-lived certificate. Maybe it only lives for a couple of hours. And Alice can use it to get access to this target. And, you know, the certificate's got the name of the issuer, her identity, and the signature of the issuer.
Right. But it's worth noting that, you know, the big advantage here is those end users, those end machines don't need to know anything about Alice in advance. And there's nothing that says this credential has to be short-lived. In fact, when we think about a web server certificate, which is the same thing, or a client certificate, often those have 1 year long lifespans or multi-year, and that can lead to sort of the challenge here. So why don't you walk us through an incident that exploits this, Sharon?
Yeah, so this is actually one of the things that I've been teaching in my cybersecurity class for 10 years, because it's 10 years old. But it's really like a watershed moment, I think, in security for at least for TLS. So this is what happened. So there was a certificate authority that was serving assets in the Netherlands. They were doing, like, you know, the Dutch RMV and things like this. And they were able to issue certificates. And the way that they issued certificates, like I showed in the previous picture, was that they would sign them with their key and give them to whoever needed them. And those were used to establish TLS connections. This Dutch CA was actually trusted broadly across the world because their key, that yellow key that you see, was baked into a lot of different browsers. And so even if I wasn't in Holland, but I wanted to access the Dutch RMV, I could, like, get a certificate from Diginotar that would validate that the Dutch RMV is who they say they are, and then I could go visit their website securely. However, what happened? This attacker, and we still don't know who this was, stole the certificate authority key, compromised that key, and started issuing bogus certificates for whatever it wanted. What it actually ended up issuing was a certificate to Google, so that it could impersonate Google and decrypt all the traffic that was going to Google. And what it ended up doing was reading and introspecting on Iranian users connecting with their email. And this is what ended up happening here. And why did this whole thing happen? It happened because the key, the signing key for the certificate authority, was not securely protected. That was the flaw. And so
that's one flaw, because there's some more flaws here,
true,
Sharon.
yeah.
So why don't you walk us through some of our takeaways?
Yeah, so that was the sort of main thing that I wanted to say. There was this key, right? The Diginotar key that everyone was trusting, and it was acting as a root of trust for all of the browsers. And when it was compromised, you could compromise all, anything you wanted in the whole internet. That's the crazy part of this story, right? So there were two issues here. One, the fact that there was just one key stored in just one place at Diginotar, which Diginotar apparently didn't do a good enough job protecting. And the second thing that was the really crazy thing about this is the overbroad scope. So like, why is my web browser trusting this weird little Dutch certificate authority? Why should I trust it, to give certificates to Google, which is not in the Netherlands at all, right? And this Dutch CA that was supposed to be serving the Netherlands only was not scoped only to Dutch assets. It was actually scoped to the whole internet. And therefore Google got compromised. Google was not compromised, but therefore they could issue a certificate. The attacker could issue a certificate for Google. So like bringing this back to the zero trust story, right? When we see these modern systems that are being based on short-lived certificates and certificate authorities, for me, you need to go and you need to look at them and say to yourself, wait a minute, have we just created a very strong point of compromise where the certificate authority's key, if stolen, could compromise my entire infrastructure? And what is the scope of this key? Is this scope so large that I can compromise like all my clouds and all my infrastructure? Just imagine how sort of risky that could be if you're basing your access on a certificate authority. And I think at this point we're saying stuff that's obvious for TLS, but I don't think yet obvious in the zero trust market.
Absolutely.
All right, so this is I've got to turn this one over to you because I've never done much work with AD. So
yeah. So there's lots of ways to administer a Microsoft domain. And there's great ways and there's the out-of-the-box ways. And what often happens when you're administering a domain is your domain admins have an administrative credential, and this is often their password, but then it gets converted into sort of a ticket that they're going to move around. And what happens is, they often do their work from some administrative server. So they log in with the credential, and now they're on that system with their credential. You notice it's very similar to the Bastion host. And then they're going to do systems administration. And so they're going to reach into a machine and do software updates or configuration changes. And again, they often are using the same administrative credential. This is not a requirement, but it is basically the default out of the box. But you notice now this credential is in a lot of different places in the environment. And that can be a problem and a challenge for a lot of enterprises. And so I want to walk you through sort of what happens to a lot of entities in NotPetya. So NotPetya is some ransomware, and it used a watering hole attack in the supply chain. So it didn't even wait for users. And for those of you not familiar with watering hole attack, that's where you compromise something and wait for people to come to you, the same way that you might, as a bandit, wait at the watering hole for a caravan to come to you. And in this case, it was a Ukrainian tax software that if you did business in the Ukraine, you had to connect and get a software update on a regular basis. And it happens that the admin is logged in, software update happens, and that machine is now compromised, and there's administrative credentials available. This also had fallbacks where it would, spread lateral using exploits. But what happens is once you have this credential compromised, now that malware is able to spread in the environment. And so it's just going to move simply through the environment, compromising more and more machines until it ends up basically with your entire environment if you had sort of one simple environment. And of course,
does the adversary have to wait for me to show up on this box before it steals my credential?
Well, it actually doesn't really need to in this case because you're there triggering the software update sometimes. It might need to wait. that's why it's going to look for other ways of spreading as well. So this one is sort of a combination of that lack of network segmentation and the single level credentials. And so once the machines are all compromised, it's ransomware. And so ransomware does what ransomware does. And that is, it's going to sort of basically wipe all of these machines. I guess technically it encrypts them, but from the point of view of your business now, that encryption has completely destroyed your business. And so we saw major, pharmaceutical companies, shipping companies were out of business for multiple days trying to recover from this. Recently, we've seen now the Colonial Pipeline, we've seen meat packing. And so this is a very common attack that happens, comes in different ways, but it's really about the ability of ransomware to move laterally within these environments that tend to have sort of one tier of administrative trust.
One tier of administrative trust, right? So that's the key here. Like when I saw this, by the way, I was like, the first time Andy showed this to me, I was really surprised to see that the same admin credential was just working across all of these machines, right? And that's the part that's sort of like incredible in 2017, using the same admin credentials across all these machines, even though this is apparently a very common way to do things. Right?
Because it's the easiest way to do it. It means that your administrators don't have to think really hard about it. A best practice is to tier these, and you say, you have one administrative credential for administering laptops and a different one for servers and a different one for the domain servers. But those are still a pretty broad scope. You don't tend to have this short-lived credential that only works at that one point. The software supply chain, clearly also a problem here. A challenge when you're forced to use a piece of software. So it's not like you can do a whole lot of vetting, but you're getting a software update onto a live running machine in a production environment. That's a recipe for some danger.
So to summarize, right, I think what we're seeing here with this one, if I take a step back, is like, again, we're seeing a standing credential, that admin password. And it's not just like a single credential for a single machine. Like when I think in the Fluffy Bunny case, maybe there could have been a separate SSH key for each one of the targets in that environment, right? In this case, there's a same administrative password that's allowing you to access all of the machines in that environment. And that part is that, like, that's the kind of the crazy part, at least if you look at this from 1,000 feet, like how could it be that there's one credential, but apparently this is common.
That's very, very, very common.
Right.
So why don't we look at a different one now?
Okay, so let's kind of go back to sort of the more modern approach to this, the zero trust approach. So this picture looks almost identical to the certificate authority picture that we had before, where what we had before was that there was a certificate authority issuing a short-lived credential. And so this, again, this is a very unlike the AD case where we have a single admin password that accesses all the boxes. What we're going to do is every time a user comes in, Alice or the admin or whoever, she's going to authenticate to the identity provider. She's going to get a token. The token is going to identify her. And the targets are going to validate that the token is correct and allow her to come in if she has a valid token, right? But again, this looks very similar because once again, we have this signing key that the identity provider uses, very analogous to the signing key that the certificate authority provider uses. And so, we get the benefits of zero trust where we have a short-lived credential, right? This SSO token. We can have authentication to this authority. We can have the authority deny access if you don't need access to a particular target, right? So we can segment our network. So this is really nice. But Solarwinds, okay? So let's talk a little bit about the ways that this can go wrong. So the Solarwinds attack in 2020, we're now at sort of the end of our historical story, is almost like the modern equivalent of the Diginotar incident, but this one is sort of affecting individual enterprises. And so what was happening here was the adversary did compromise some targets on in the customer's environment, in the victim's environment. So imagine this thing gets compromised, and the adversary manages to actually steal the identity provider's key. And I have a typo in the slides here that should say identity provider. So the adversary manages to steal the identity provider's key, and now because it has the signing key for the identity provider, it can issue SSO tokens for itself and basically access any part of the network that it wants, right? So this is almost the same as what happened with Diginotar, where you had fraudulent certificates. What you have now, because the adversary stole the key, what you have now is, again, you have fraudulent SSO tokens because the adversary stole the key. So Andy, I mean, what do we learn from this, from this incident amongst all the other things that sort of we've taken away from SolarWinds?
I think we see some of the same lessons we've had before. That single root of trust is very dangerous when it has that overbroad scope of authority, and when it's just one entity. If that entity gets breached and it basically has administrative access for your entire enterprise, then you're going to have a really bad day. And of course, they did originally come in through the software supply chain, so that is something to pay attention to.
And so what do you have to say about this particular incident in light of the fact that so many organizations are moving to an SSO model for access to different parts of their networks?
I think looking at, how do you actually authenticate that this is the user who's doing it rather than somebody who's not the user? And maybe that's velocity detection on the user's movement. Maybe it's MFA, but out of band. A lot of people implement MFA to the IDP, but if the IDP's key has gotten stolen, that's not going to help you, because, the adversary can create something. But if you're doing a second factor at the server, potentially that provides you a second root of trust. You're verifying that they have an SSO token and some form of MFA or a certificate authority that came from somewhere else. So I think a lot of different things here. But I think
I'm going to say a word that Andy hates, which is defense in depth, right? so we're not going to have this debate right now, but I think one of the things that is interesting for me and really has driven some of the stuff that we've been working on for the last year is the idea that, this single root of trust for access to all of your targets and all of your networks, be it you're a certificate authority or be it an SSO provider, this is not necessarily the best way to do things, right? We want to see, more than one root of trust, more than one place that if it's compromised, everything falls down. Right. So in another sense, it's again, this notion of overbroad scope, single root of trust. This is very dangerous in terms of securing your systems. So we've just taken our tour. Our tour is complete. Five incidents that Andy has lived through and I've watched from the sidelines. I think we have a couple of a few principles that I think we should wrap up with. Andy, do you want to kind of walk through?
Yeah. I think we've walked through some of these, verbally, but I think the key here is that safely implementing secure access, lots of different ways it can go wrong. Whether it's that single root of trust instead of multiple ones, you're using long-standing credentials instead of ephemeral ones, single flat architectures instead of segmented ones, and weren't paying enough attention into the supply chain and ways that could create a problem for you. So we really appreciate everybody's time in joining us, and we hope that this helps illuminate a path to a safer world as you're all designing systems.
Thank you.